action. All right, so yesterday we were building linear functions, right? Today is exponential. The only difference is, remember, what does a linear function look like? It's a line. So we have a linear function, you know, and maybe like some of the homework problems, it started at 0 and it just kind of went up. Some went in both directions. Exponential, remember, goes up like so. So as it keeps growing and building, the exponential is going to grow faster. Okay? It's not going to be like we go 1 unit and we go 1 unit. We go another unit, we go up another unit. It's not where we have the consistent steps, right? That's linear. That's what we were doing yesterday to find the change. The slope was the change between each point. Here, we got a step like this, then we got a step like this, then we got a step like that, then we got a step like that, right? Because the steps are getting bigger as you go along. It'd be the same thing as here, if you had 2, what's 2 plus 1? 3, plus 1, 4, plus 1, 5, right? That's where it's consistently growing. The rise over run, the growth is each number I do, it just goes up 1. Here, what if we had 2 and I had to multiply it by 2? 2 times 2 is 4 times 2 times 2 times 2 times 2 times 2.
128.
28 times 2.
256.
Times 2.
3.
512. Times 2. I used to do this in my head when I was in elementary school. So we drove to my grandparents' house a lot, neighborhood city. So it was like 2, 4, 8, 60, 32, 64, 128, 256, 512, 1024, 2048. That's our game, 2048. It's all related.
That's insane.
Yes, it is insane. I didn't know them, but I was doing geometric sequences at the age of 8. So it comes in handy to have those numbers worked out. Do you see how this is growing different, though? The change isn't the same between all of them. I mean, it's a multiple, but it's not going up where it's just like go up 1, go up 1, go up 1, go up 1. So that's what we're going to be dealing with. Remember, you know this already. Initial values are A. The B is the growth or decay factor. We're going to call that the ratio of change for these kind of problems. Okay. The ratio of change, and over there was multiply it by 2. Multiply by 2, whatever you get your answer there, multiply by 2, whatever answer is multiplied by 2. Okay. So in that case, that sequence over there, it would be 2. It would be 2, and this would be 2 as well because you're doubling everything as you go. Okay. We're just going to have to figure out, the initial value isn't going to be hard to figure out, but the growth factor, we got to do a little bit of work. Okay. So let's look at this. Always start with 0. Why do we start with 0? Because that is the what value?
Initial value.
Initial value. Perfect. So the initial value, if I'm putting this information over into my equation, what should I put in for my initial value? 2. You always look. This is our initial value. Initial value. If you didn't write that, maybe go ahead and put that in. When x is equal to 0, we got our initial value. And that node will help you. That node will help you. Later on, oh, when was it? Where was it? Make a little note. Doing your homework later, no problem. Now, it's very important too. We have to have it sequential. So I say always go with 0, 1, 2, 3. 0, 1, 2, 3, because we want to see what the change is, what kind of step we get between each number. From 0 to 1, what kind of step? From 1 to 2, what kind of step? If I went from 1 to 12, then I'm talking about what is the step over 12 units. I want to know from 0 to 1, here's my step. 1 to 2, another step. 2 to 3, and we'll be able to see the growth if we do it in sequence like that. So always 1, 2, 3, or 0, 1, 2, 3. Just like yesterday, how we had here, we were finding the difference. Now we got to just find our ratio of change. What kind of change happens between each sequence, each sequential step. So since this is the initial, nothing happened before that, hypothetically in the situation, so I just put a line through it. You don't need to do that one. But just like before, to find the difference, we're going the current minus the prior. This is the current divided by the prior. So you see how I have 8 divided by 2. I want you to do the rest for here and find the actual value. Find our ratio of change for all of them. So you're going to fraction here, fraction here. What goes here? What goes here? Find your answers. Go for it. Check with your neighbor. If you're not sure, you need a hint. You need a hint? Check. You are. Okay. Oh, whoops. Whoops. I'm going to change that. I'm going to pause this. All right, let's look at it again. Are you helping?
We already finished.
Oh, okay. Okay.
We're just chilling.
All right, all right. So you can help me out with this?
Sure.
No problem. What goes here?
32.
And
8.
what does that give you?
4.
What did this give you?
4.
Don't sound so bored. What goes here?
128.
With gusto. What goes here?
32.
That was kind of aggressive. What goes here? No aggressive with gusto.
4!
Jeez. Well, that worked out. You're just excited about the number 4. Is that it?
Yeah.
Okay.
What's my favorite?
You play golf? Is this in common, guys? Is that in common? Can we say it's a common ratio of change between all of them? Yes, it is. So guess what goes? What this is?
It's the growth. And the end.
Done. Done.
Done.
Ta-da. All right. How about this one? I want you to. This one's slightly trickier. I want you to do the same exact process, and I want you to fill in your A and your B. The X is always going to stay the same in these problems because they're not situational. These are abstract. Question. All right. So remember, this one we can't really find anything because there's nothing that happens before it. It's X is 0. We don't need to go past that in general. Yeah.
Well,
Okay.
the X, like, exponent
Yes.
thingy, is that just the, is that like a new one to be? Like, what?
Yeah.
Okay.
Now, if you plugged in 1 right here, let's see what happens. See what happens. So 1, put it right here. 4 the first. 4 times 2. Okay. So we didn't have to plug them in because essentially we found this. We found this from our table. So we know it works. We know it works. Question? Oh, you have the answer for it. Okay, you have the answer too. You want to help me work this out? Let's give it another 10 seconds. We gotta watch out for others. I haven't seen that one before. Do it again. Wait, I have seen that one before. That's a Sutter thing, huh?
No, we just chilling.
Is that your answer for everything right now?
Just chilling.
Just chilling. Nate,
Yeah.
what goes right here?
A 20. 10.
What goes right here?
Oh, I haven't done it
The answer is just chilling. Everything is just chilling.
yet. Oh, just chilling, yeah.
Just chilling. That was lame. Let's do it. What goes here?
Just chilling.
Good. What goes here? Good. What goes down here? The prior, right? 20.
Just chilling.
Just chilling. Here? 5. 10. Here? 5. What do all these give you? Perfect. What was our A value, though?
28.
God, you're so good. You don't even know. It's so easy.
Yes.
What's our ratio of change? 1/2, 0.5, whatever you want to put there. I think we'll keep it consistent, all decimals here. 20.0, 0.5.
So since it's decay, but could it be like a negative number since it's
Right. And the thing is that I like this. Very good, very good. So, good question came up. Why isn't this negative? Why isn't this negative 0.5? Because it's some kind of decay happening. But here's the thing. Watch. Remember, it was 1. If this is decay, and it looks like it's getting smaller. Yeah, decay. 1 minus the rate is how we set up the decay. So we actually don't end up with negative values for the growth. we only end up with either decimals, which means it's smaller, or a whole number or larger than 1, which means it's getting bigger. So those are the two options. You won't end up with a negative base in this case. Rhyming. All right. Any other questions coming up with this? What's the hard part? Somebody answer Candy Crux. What's the hardest part about this? Yes.
I feel like identifying like whether like Genevieve said for me I was confused whether it was negative, like why was it negative?
Why wasn't it negative? It's good. Well, we know when we have a decimal, then we're going to end up getting smaller. Actually, if we had, think about it this way, guys. If this ended up being, think about it. If this ended up being negative 1, okay? Negative 1. If the exponent was squared, too, what would we end up with?
Positive.
A positive 1. Okay? If then negative 1 to the third power would be negative 1 times negative 1, positive 1, times another negative 1, be negative. We'd end up with this function that's kind of like all over the place. So sometimes if you do the scenario, well, what if you do the scenario, if that doesn't make sense to how we know they look, exponentials, then you know that that rule is kind of recursively figured out. You see what I mean? Okay. It's good. You guys are doing great. All right, thumbs up, sideways, or down for this lesson. Yeah. If you're sideways thumb for Candy, can you tell me why?
That means Jay chilling.
Just. Do it again. What?
Jay chilling. Oh wait, was it backwards?
I don't know. Is this backwards?
You're doing 2 C's. You gotta be like boom,
This is.
boom, Jay chilling, and then boom.
I'm like JJCCC, JJC. Don't you know what that means? Just chilling, chilling, chilling. Just chilling, chilling.
You're the stutter.
That's stutter. Yeah, that's stutter sign language. All right, guys. It doesn't sound like we are going to get one of those. So no worries. Subscribe. I've already eaten the Kit Kat. I'll buy one once it gets to 250. I have like 300. No, that'd be awesome. 236.
I subscribed.
You what?
I subscribed.
You did?
Well, last time I subscribed, it was like